I'm just going to talk through a little bit of what I found interesting in Chapter 1, and then in another video I'll do some example problems and work through some stuff. So in Section 1, I just wanted to point out the definition of science. It's the process of trying to understand the natural world by making observations, taking measurements, and most importantly, I think, is testing the ideas. In Section 2, we introduce some terms that we use in science, and that way we can just all be on the same page. If we say hypothesis, let's just take that to mean an initial guess that can be tested. A scientific theory is going to be a well-tested explanation of natural phenomena. And scientific theories are going to encompass laws and facts and kind of be an overarching idea, like the theory of the Big Bang. It encompasses a lot of laws and facts that we've already tested a lot, and it has made a lot of predictions that have come true. That doesn't mean that that theory is perfect. It just means that it hasn't been proven wrong yet, and it encompasses all of these other facts and laws that have been tested. So kind of in that same idea, we have scientific laws and scientific facts. Again, in order to kind of achieve that title, they have to have been well tested. And that means repeated by different people in different countries, and people get the same results. People have tried to prove them wrong and have not yet been able to. A scientific law is usually relating a cause to an effect, and a fact is just more of a measurement or an observation. An example of a scientific fact might be the acceleration of gravity. Objects near the surface of the Earth are pulled down with an acceleration of 9.8 meters per second, and the scientific law would explain why that happens. Now, our scientific facts, laws, and theories must be modified or discarded if they are ever shown to be false. And I know I use the word theory in unscientific ways, like I have a theory the restaurant is going to be busy tonight. That's just me using the word theory in common English. But if I'm talking about a scientific theory, I would be talking about the theory of the Big Bang, the theory of evolution, the theory of gravity. Now, all of those are implied to be scientific and well tested. Not necessarily perfect, but well tested. I'm sorry here, my text broke over page lines when I exported it from my iPad. It was supposed to say this law breaks in certain cases. So my general example of the fact that theories can be improved as we get more information is the law of gravity. So the law of gravity, which dates back to Newton in the 1600s, tells us that the strength of gravity's pull is dependent on the mass of the two objects and the distance between them. So this scientific law is basically an equation. We can figure out how hard gravity is pulling if we do this math where we plug in a constant, the amount of mass 1, which might be the mass of the Earth, the amount of mass 2, which might be my mass, and the distance between them. And then that would be the distance between the center of the Earth and me. And we could figure out how hard gravity is pulling on me. And this is a scientific law because it relates a cause to an effect, and it has been really well tested. But Newton's law of gravity breaks in certain cases. So really, Newton's law of gravity isn't perfect. We only use it in certain simple cases. And in the more complicated or extreme cases, we have to use the theory of general relativity. So we know Newton's law of gravity isn't completely true. But so far as we know, the theory of general relativity is. And that will probably change in 50 years as we learn more. But in the simple cases, we still use Newton's law of gravity because it still works. So overall, the moral of this story is, our theories, laws, and facts are well tested. We do trust them, but we always leave open the possibility that as we learn more, we will have to change them. We will have to either upgrade them or just completely get rid of them and start from scratch. Section 3, you can read it if you want to. I'm not going to cover it.